Alright, we are going to be talking about multiplier resistance. So we talked about shunts, so now we're talking about multiplier. So just note this down. This one I have it there. I said a galvanometer can be converted to voltmeter by connecting a high resistance multiplier in series with the galvanometer. So take note of this. How galvanometer can be converted to voltmeter. Alright, so looking at this picture, if you see this picture, you should know that this is a multiplier, the image of a multiplier. So this R here is representing multiplier resistance. You understand? That multiplier resistance. And this small R here is representing galvanometer resistance. You see that this is the symbol for galvanometer here. Whenever you see this, either galvanometer comes in this or it comes in this. Share you get. And I said galvanometer can also be called MCM. Moving coil meter. I believe you understand in last class. So it's either you call it galvanometer or MCM, moving coil meter. So it's either it comes in this symbol or it comes in this symbol under basic electronics. Alright, you can see this V1 is under this multiplier, so we call it voltage across the multiplier. Alright, so you see this V2 is below this resistance of galvanometer, so we call it voltage across galvanometer. This is a symbol for multiplier, this is a symbol for galvanometer. So that's it. So what is now this IV? This is the current flowing through the galvanometer, because it always comes from here and move to the body part of it. So whenever you want try to find the multiplier resistance, so the equation is given by your V over IG minus what? Minus R. Right, shall we begin to solve this problem? Let's solve this problem right away. Right, away. Okay, let me clean this guy. Talking about multiplier. Multiplier is very simple. Very simple. I think this page is really okay. Let me use this guy here. Sorry for using my hand. It's a bad habit, so I have no choice. I have to use my hand. So, but if you want to get a full mark as a white student, you have a question like this: a moving coil with an internal resistance 1000. Okay, that is not 1000. Has a full scale deflection or whatever. Okay, it is very obvious that this is a multiplier question, right? In the multiplier, you have this guy. Okay, you have your galvanometer here deflected to the right hand side. Then this comes out. Don't forget, then you're having this guy. Okay, then you also have a hand here. Okay, so at first you should have your. We are now having V1 in this question, so I suggest that we just have our V in this question. What's our V? Our V is 10 volts. Okay, so in this place, this is where the arrow comes in. Don't forget, so this is the current flowing through the galvanometer. So let's reach a moving coil meter with an internal resistance of 1000. Internal resistance of 1000. What is the internal resistance? The internal resistance is this. Remember that this one is external resistance, this one is internal resistance. So, but we know that literally this one is always internal resistance. But in this topic multiplier, it's the resistance of the galvanometer. So the resistance of the galvanometer is also the internal resistance. Don't get confused, okay? So that our R here is 1000 ohm. Okay, even if you are not given the unit, you should know the unit. Okay, when a current of 10 milliampere, so our current, okay, when a current of 10 milliampere flows through it, okay, it flows through it, definitely that's the current of the galvanometer. We are having 10 milliampere here, so you have to convert this guy to 10 times 10 raised to the power minus 3 ampere, which will later give us 1 minus 3, that's 0.01 ampere at the end of the day. Okay, that's 10 raised to the power minus 2. Am I correct? Yes, 10 raised to the power minus 2. Alright, so moving on, we have what else do we have? What else are we looking for? You are looking for the multiplier resistance, the multiplier, the big R. We are looking for this guy here. So remember that your R here is equals to galvanometer minus R. Let's substitute our values. What's our V? Our V here is giving us 10 divided by what's our IG? Our IG is 0.01. Then minus 1,000. You say 1,000. That's my calculator. Alright, so yeah, I have 10 divided by 0.01, and okay, I have 1,000. How can I have this? Let me see. Okay, okay, our V is 100. Sorry, I know we cannot have this, so I make a mistake here. So our V is 100, but sorry, let me correct that, because it's going to be giving me 0, so it's not making any sense. So where's my V? My V here is 0. So let's see. 100 divided by 0.01. So I have 10,000 minus 1,000. So 10,000 minus 1,000. Okay. I have 900. I have 900. 900, yeah. That is what I'm having at the end. 900. Oh, understand? So that's my final answer. My final answer is 900 volts. Okay, so it is very simple. That's the end.